Welcome students. Today we are going to discuss about digital to analog converters, that is DAC, in our coursework of analog circuits. Myself Dr. Kirti Vyas from Arya College of Engineering IT. So we start with the topic of digital to analog converters. There are basically two types of DACs. First is weighted resistor network and R2R ladder network. We get started with the weighted resistor network. The circuit diagram for a weighted resistor network is shown in this particular slide. As you can see, the reference power supply is plus 8 volts. That means if the bit is 1, the voltage of 8 volt will be applied, and if bit is 0, then we have connected all the terminals which are connected to the resistors via a switch can be also be connected to the voltage 0. A is denoted as MSB and D is LSB, that means least significant bit, and MSB is most significant bit. If all the bits are 0, that means for a 4-digit number such that A, B, C, D are all zeros, the switch are connected, which is shown in the slide. If the bit is 1, then the switch will be connected to plus 8 reference supply. The resistor values are 1K, 2K, 4K and 8K, that is, they are weighted inversely with the value of the current flowing through them. A is most significant bit, and if A is 1, it corresponds to 8 in decimal number, or the current is maximum. Therefore, the corresponding resistance is low. If D is 1, D here is least significant bit if it corresponds to 1 in decimal system also. The D corresponds to 1 in decimal system also. Next, we talk about how this particular circuit is going to work. The resistors are weighted against their decimal values, and hence they are called weighted resistors. If A, B, C, D are 0, 0, 0, 0, the output will be 0 milliampere. If it were 1, 0, 1, 0, the output current would be 8 plus 0 plus 2 plus 0 equal to 10 milliampere. We take one more example. If it was 0, 1, 1, 0, then output would be 0 plus 4 plus 2 plus 0 equals to 6 milliampere. Therefore, the output current represents the decimal equivalent of the binary number. Thus, the digital input is converted to analog signal because if the binary input changes with time, the output in decimal form also changes with time. The output is shown in the figure in the next slide as figure 5.2. If a capacitor is chosen, the output will be smoothed out as shown in the figure 5.3. This is how a weighted resistor network as shown in the slide works. Next, we move to the second topic, that is R to 2R ladder network. Now let's look to the circuit. This is how the circuit looks. As you can see, it looks like a ladder, hence name so. The circuit is consisting of 4 input A, B, C, D, which you can see A is most significant B, that is most significant bit, that is MSB, and D is least significant bit, that is LSB. If the all bits are 0, the switches will be connected to ground, so the current will be 0. Suppose if A is 1, A, B, C, D are zeros, and hence A will be connected to +8. The equivalent circuit are shown in the particular diagram 5.5 A to G. This is how the equivalent circuit will look like. And these particular circuits can be used for simplifying and analyzing the circuit. The total resistance of the circuit is, as you can see in the last G part, is R2R1 plus R1 equals to 3R1. The total current will be I equals to E by R, that is 8 volt upon 2R1. This particular circuit is shown in the figure 5.6. This is the simplified equivalent circuit. The current flowing through the ammeter is I by 2, which is 4 upon 3R1. Suppose now if B is connected to +8 and other switches are ground, that is the digital binary output, that is the digital binary input given is 0, 1, 0, 0. The equivalent circuit is shown in the figure 5.7. This is how the equivalent circuit will look like, and the current value I will be equals to 8 volt upon 3R1. I gets divided into I1 and I2. I1 gets equally divided into I1 by 2 and I1 by 2 value. So we simplify and we find that the current value flowing through the emitter will be equals to half I1 equals to 2 volt upon 3R1. Now we take one more example. If A equals to 1, the current to the ammeter is 4 volt upon 3R1. If B is 1, current will be 2V upon 3R1. If C equals to 1, current through emitter will be 1 volt upon 3R1. If D equals to 1, the current through the emitter will be 1 volt upon 6R1. Therefore, the current is proportional to the weightage of each bit A, B, C, D. This digital signal is converted to the analog form. This is how this particular circuit works. The advantages of the circuit is there are only two types of resistance, 2R1 and R1, compared to different values in cases of weighted bridge. Accuracy here is much better than the weighted resistor network. The disadvantage of this particular scheme is the reference supply here need to be constant, and second disadvantage is more number of resistor are to be used compared to weighted resistor type. Thank you for listening to this particular lecture. In next lecture we will talk about more into DAC.